Welcome to Newton Gates Success Strategies Academy, where we make your dreams come true. Today, we will discuss about a very important topic of Class 9 CPSE Physics, that is sound. In this video, I will discuss about the production of the sound, propagation of the sound, characteristics of the sound waves, distinguishing factors of different sound waves, reflection of the sound, and structure of the human ear. First, let us discuss about the production of the sound. Sound is produced due to the vibration of the objects. Now, the sound which you are hearing is due to the vibration of my voice box. Vibration is a rapid to and fro motion of an object. Vibrating objects are the source of all sounds. Irregular, chaotic vibration produce noise regular. Controlled vibration can produce music. All sound is a combination of pure frequencies. A stretched rubber band, when plucked, vibrates and produces sound. So these are the examples by which you can produce sound in your day-to-day life. Now, next we go to the propagation of the sound. When an object vibrates, the particles around the medium vibrate. So considering a figure like this, these are the molecules of the air. So whenever any sound is produced, these molecules are vibrated and comes closer to another molecule. Then this molecule pass on the vibration to the next molecules. So in this way, it reaches our ear. That is the human ear. So we can say that whenever this vibration disturbs the air molecules, it goes into our ear and hence we are able to hear the noise. Next, the disturbance produced by the vibrating body travels through the medium, but the particles do not move from their own positions. A wave is a disturbance which moves through a medium by the vibration of particles of the medium. So, sound is considered as a wave. Sound waves require medium for transmission. In vacuum or in space, sound wave cannot travel. So, it either requires a medium like atmosphere, that is air, solid, or any liquid. When vibrating objects forward, it pushes or compresses the air in front of it, forming a region of high pressure called compression. When the vibrating object moves backward, it forms a region of low pressure called the rarefaction. I will explain this in the next slide. Here, let us take an example of a propagation of sound produced by tuning fork. Here, the sound have been produced by striking the fork into a metal surface. We can see that there are regions of high pressure, those are known as the compression, and a region of the low pressure. This is known as the rarefaction. So this is how the sound waves propagate through any medium and reaches our ear. Now, the nature of the sound waves. Sound waves are generally transfer waves. There is another kind of waves called transfer waves. In this waves, the particles oscillate up and down perpendicular to the propagation of the direction of the disturbance. Sound wave propagates in a medium as a series of compression and rarefaction. Compression are the regions of high pressure, as discussed earlier, where the density of the particles are crowded. That means the density is maximum, are represented by the upper portion of the curve called the crest. So if we make a curve of the sound wave, we can see a picture like this. This upper part is for the compression, that is a region of high pressure. And this lower part denotes the rarefaction, that means a region of low pressure, where the density of the molecule is the rarest. Now let us discuss about some of the factors that is the characteristics of a sound wave. We know it travels in the form of wave, so it exactly looks like wave. Now, let us discuss what is wavelength. Wavelength is the difference or the length between two consecutive crests or trough. So, if these are two crests, the distance between two consecutive crests is known as the wavelength. That is, the distance between two compression is known as the wavelength. Wavelength is generally denoted by the lambda and its SI unit is in meter since it is length. In this side, we represent the pressure. This is the area of condensation, that is compression, and this is the area of the rarefaction. Now, let us go to distinguishing factors of the sound waves. First, distinguishing factors means how can we distinguish two sound waves given to us. First, the frequency of the sound waves. What is frequency? The number of oscillation per unit time is called the frequency of the sound wave. It is represented by the symbol nu, that is Greek letter nu, Nu. It is represented as this. This is not V. It looks like V, but it's not V. Its SI unit is Hertz. Next, we come to the time period of the sound wave. The frequency and the time period are represented as follows. We can consider frequency as inversely proportional to that of the time period. So the expression is given by time t equals to 1 by nu. Next, the amplitude of the sound waves. The amplitude of the sound wave is the height of the crested trough. It is represented by the letter A. Means the height after which the crest or trough has gone is known as the amplitude. It is again measured in length, so its SI unit is meter. The SI unit is same as that of the density of pressure. The wavelength is the distance between the crest or two waves that are next to each other. The amplitude is high the crests are. Our amplitude is how high the crests are. Next is pitch and loudness of the sound. The pitch of the sound is known as the straightness or flatness. It depends on the frequency of the vibration. If the frequency is high, the sound has high pitch. If the frequency is low, the sound have low pitch. So, a diagram of high-pitched sound can be considered as like this. Because here the frequency is maximum. So that means it is having high-pitched sound. Whenever the frequency is less, this means this is the low-pitched sound. Next, speed of the sound. The speed of the sound is more in solids, less in liquids and least in gases. Because in solid, the particles are very much close to each other. In liquid, they are little farther, and in gases, they are the farther from each other. The speed of the sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of the sound is also more. Next we come to the reflection of sound. As like the light, sound also suffers a reflection. The sound gets reflected at the surface of a solid, liquid and follows the laws of reflection. First, the angle of incidence is equal to the angle of reflection. For example, if the sound is receiving from a bell, it again reflects in the same angle to our ear. So that means angle of incidence is equals to the angle of reflection. Second, The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. That is, the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Next, let's discuss a very little about the structure of human ear. The sound waves passes through the ear canal to a thin membrane called the eardrum. The eardrum, when vibrates, these vibrations are amplified by the three bones of the middle ear called the hammer, anvil, stirrup. Middle ear then transmits the sound and waves to the inner ear. The brain then interprets these signals as sound. So if we consider the diagram, this part is the outer ear or the receiver. Then it goes to the middle ear. It contains eardrum. The sound travels through the ear canal. Then again it goes to the inner ear where there is a cochlea. And then it goes to the auditory nerve, and hence the brain recepts it and consider it as a sound. Hope you like this video. Please like, subscribe and share our YouTube channel Newton Gauge Success Strategies. For more details, please visit our website www.newtondate.in.